in section 1.3, we're talking about the same things, linear equations, looking at the graph, looking at the slope, which is the average rate of change, and we're just doing more practice with graphing and modeling with lines, okay? Problem 1 is a media example. We're asked to draw an accurate graph for y equals -2x plus 6. Identify at least 2 additional points on the line and label them on your graph. So first, if you're given an equation in slope-intercept form, the very first point that you should plot is the y-intercept. So for y equals -2x plus 6, m is equal to -2, and b is equal to 6. So the y-intercept is the point 0, 6. That's the first point that you can plot. We'll just make our scale 1 here. So if we do 1, 2, 3, 4, 5, 6. Oh, sorry, I can't see the little tick marks. I'm going blind, y'all. 1, 2, 3, 4, 5, 6. This one's 6. Yeah. All right, so that's the point 0, 6. We have 1 point done. Then we can use our slope to help us find additional points on the line. We should label these points as well. If the slope is -2, that represents the rise over the run, you can think of this as -2 over 1. It's your rise over run. So you will go down 2 units and to the right 1 unit to find an additional point on the line. Let's do that and then label at least 2 additional points. So this one was 0, 6. Okay. 0, let's try again. 0, 6. And then if we go down 2 units and to the right 1 unit, we get to this point, which is 1, 4. And then we can do this again. Down 2 units to the right 1 unit. This gets us to the point 2, 2. And then we can continue on even again. Down 2 units and over 1 unit. That gets us, what's this? 3, 0. All right, so I did even an extra point. If we connect all of these dots, we get a graph of our line. So you can plot your y-intercept and then use the slope to help you find additional points. Or if you don't want to use the slope to find additional points, you can do it as we did previously, where we pick a value for x and plug that in to find a y. All right, then let's look at this next box. Writing the equation of a line. Critical to a thorough understanding of linear equations and functions is the ability to write the equation of a given line, given different pieces of information. So sometimes you might be given the slope and a point. Sometimes you might be given the slope and a y-intercept. Sometimes you might be given 2 points. Sometimes you might just be told, oh, I want a line that's parallel to this line, but it goes through this point. Depending on the information you're given, you should be able to find the equation of the line. The following process will work for almost every situation you are presented with and will be illustrated several times in the media problems to follow. Okay, so follow these steps and you'll be able to find the equation of any line. This is what we'll be practicing today. Very first thing you want to do is try to find the slope of the line. Okay, so if you're given 2 points, y2 minus y1 over x2 minus x1, find the slope. Sometimes you'll just be directly given the slope. Then identify 2 coordinates for an ordered pair. So find an ordered pair or a point on a line. You're usually either given that, or if you're given the equation, you can plug in an x and find a y to get an ordered pair. Yeah, you'll be given a point or some information where you can identify an ordered pair. All right, then you're going to take the slope-intercept form, y equals mx plus b, plug in the slope m and your x from the point and your y from the point, and use that to solve for b. And then once you have your slope and you have b, that's enough information to write your equation in slope-intercept form. Okay, so you want to write it as y or f of x equals mx plus b. Number 2 is a worked example. So that's boring. It's already done for us. Let's go to number 3, where we try. All right. It's nice to go through the worked examples. So if you're on homework and you get stuck on something, you can always go back to the book to look at the worked examples, or also go to the link for the media examples so you can see extra practice problems. So problem 3 says, find the equation of the line that meets the indicated criteria. Leave your answer in slope-intercept form. Show your work. All right. So we want the equation of a line passing through the points 1, 4 and 3, -2. This is an example where we're given 2 points and we have to find the equation. First thing we do is find the slope. I'm going to call the first point 0.1 and a second point 0.2. So y2 minus y1 would be -2 minus 4. And then we're going to divide that by x2 minus x1. Since we started with the second point in the numerator, we have to start with the second point for the denominator also. That's 3 minus 1. Then simplify this. We have -6 over 2, which is -3. So our slope is -3. And then we need to identify a point that we want to use to help us find b. We're given 2 points in the beginning of the problem, 1, 4 and 3, -2. You can use either one of those. It doesn't matter which one, you'll get the correct answer. I'm going to use 1, 4. So this gives us our slope, and the 1, 4 gives us a value for x and y. Okay. So step 1 was finding the slope. Step 2 was identifying an ordered pair x, y. Step 3 is plugging all of this into y equals mx plus b. So that would give us 4 is equal to -3 times 1 plus b. And then step 4 was to solve this. So once you have a point and once you have the slope, and you plug that point and your slope into the slope-intercept form of the equation, you can then solve for b, your y-intercept. So we get 4 equals -3 plus b. Adding 3 to both sides, 7 is equal to b. And now we have all the information we need. We just need to put it together. To write an equation in slope-intercept form, you need the slope, which we said was -3, and you need the y-intercept, which we just found is 7. So putting those 2 things together, our equation is y equals -3x plus 7. Let's keep it going. Then problem number 4, this is a guided example for us where we're given a table. And from the table, we want to write out the equation of a line. Joanna, Fred, and Kwame plan to monitor their distance covered in miles during cardio exercise over several weeks. Below is the data for Joanna's difference, or Joanna. I don't know why I'm calling her Joanna. What are those two? Joanna's distance. Does the above data represent a linear function? Explain using average rates of change. So let's look here. If we look at weeks 0 to 3, so from x, oh, what happened here? We have to calculate at least 2 rates of change and show that they're either the same or they're different. So from x equals 0 to x equals 3, delta y over delta x is going to be equal to 25.5 minus 15 miles over 3 minus 0 weeks. All right, that would be 10.5 over 3 miles per week. And if we simplify that, that's 3.5 plus 3.5. 3.5 miles per week. All right, that's our first rate of change calculation. Then from weeks 3 to 7, so from x equals 3 to x equals 7, we get delta y over delta x is 39.5 minus 25.5. over 7 minus 3. And again, that's miles per week. All right, so 39.5 and 25.5 is 14. And 7 minus 3 is 4. 14 minus 4 is 3.5. And of course, you can use the calculator to double check this. So yes, when we calculate the average rates of change, we get the same thing. We can even look at 0 to 7 if we wanted to. You would still get the same thing, 3.5. So yes, this is a linear function. Now that we know this is a linear function, we can write out a linear model in the form y equals mx plus b. Remember, one very, very, very nice thing about linear functions and the average rate of change. Once we've calculated the average rate of change and we find that it's constant, that constant number that we get tells us what the slope is. So from the work that we just did in part A, we can use that for part B. For part B, we know that m is equal to 3.5. And then also in the table, we're given information to find b. At week 0, the distance is 15. That gives us the y-intercept, so b equals 15. And then putting those together, we get the equation y equals 3.5x plus 15. For Fred's data, Fred, that's this person's name? Oh, yeah, there was a Fred up there. All right, so for Fred's data, we're not given his initial distance. So for Joanna, we were given her initial distance was 15. For Fred, we are not. So yes, we're gonna have to do a little bit more work. Also, Fred's data is set up kind of nicely for us because the x values are changing by the same amount. So we can see that like delta x here is gonna be equal to 2. And for the second calculation, delta x is again equal to 2. Oh wait, I wrote that wrong. From weeks 4 to 6, that's also a delta x equal to. And then we can look at what's happening with the y's. From weeks 2 to 4, delta y is equal to 3. Am I counting right? Nope, 4. And then from weeks 4 to 6, we go from 25 to 29, delta y is equal to 4 again. So if our table is set up where all of the x values are changing by the same amount, we can kind of quickly calculate the average rates of change using the table. So we see there from x equal 2 to x equals 4, delta y over delta x equals 4 over 2, which is 2. Same thing for x equals 2, or 4 to x equals 6. Delta x, or delta y over delta x is equal to 4 over 2. We did the work in the table, and that equals 2. So yes, this is linear. We have a constant average rate of change. That means that m is equal to 2. All right, and then that brings us to the second part. In this table, we're not given the row for 0, so we're not given the y-intercept. We have to do a little bit of work to figure it out. You can either use the table and kind of work backwards. We see that every 2 weeks, the number of miles is increasing by 4. So if we go back 2 weeks, it should decrease by 4. So if at week 2, we were at 21 miles, if we go back 2 weeks, we should be at 17 miles. You can think of it that way, or we can plug our points in to find it. Okay, so find the distance covered by Fred in week 0. That's his initial distance. If we have y equals mx plus b, we can use m equals 2, because we just calculated it, and any of the points from that table. And I'm going to do 2 comma 21. That gives us 21 equals 2 times 2 plus b. 21 equals 4 plus b. And subtracting 4 gives us 17 is b. So his initial distance was 17 miles. In part C, we can put those two things together. The slope was 2, b is 17. So the equation is y equals 2x plus 17. And then the last part is asking us to graph this on our graphing calculator with the appropriate window. So using your graphing calculator, look at, who is this? Joanna and Fred's distances from weeks 0 to 10. Compare your graph with another student. So you can all compare yours with mine. One thing that we need to think about when we're graphing, we can easily plug these lines in, but to consider the windows, you want to look at the inputs and outputs that you're given. For the X min and X max, you need to use the inputs. So we're given weeks 0 to 10, they said they want to look over the first 10 weeks. So we're going to let the X values, excuse me, go from 0 to 10. And then for the distances, notice for, who is this? Fred, his distances go up to 29, but Joanna's distances go up to about 40. So we're going to need to make our Y window much bigger than 10. We can let it go up to like 50 or 60 or 70. So we can see how many miles are covered over all of those weeks. All right, let's just graph this in Desmos really quickly. Our first equation was 3.5x plus 15, and then 2x plus 17. Now, my window isn't right. I can't see all of these graphs. I can't really get a good idea of what's happening over the first 10 weeks. Like when x is equal to 10 down here, we can't see what's happening up there. So I'm going to change my window. We're going to let the x values go from 0 to 10. That represents the first 10 weeks. And for the y values, that represents the number of miles that we're running. We can start at 0, and let's make the window big enough so that we can see both lines. We know, like we said, Joanna was at week 7 was doing about 40 miles, and then Fred, I think, was at like 20 something miles. So y needs to be big enough to see both things. Let's try y equals 75. Oh, that works. We can even make it smaller. Y equals 60. That works. Any window where you can see both of the lines clearly over the 2 weeks would be a good window. All right, so we see that if we're comparing these, that's what's wrong. I was like, why is this so low? That's better. I was going to be concerned for Fred. Like, why did he start off at 1 mile? But he started off at 17 miles. All right, so now we can see the full graphs. We can also see the intersection point. We know that Joanna started off, I'm sorry, I'm on Fred. Fred started off at 17 miles and Joanna started off at, come on, let me click it, 15 miles. But the slope for Joanna's line is higher. So each week she's increasing her number of miles by 3.5, and Fred is only increasing by 2 miles each week. That means eventually Joanna's going to catch up to the number of miles Fred runs, and then she's going to pass him. That's what happens here. So after 1.333 weeks, 4/3 of a week, 4/3 weeks, I should say, Joanna catches up to Fred, and then after that, she's going to be running more miles than him. So far, all of our problems that we've looked at have been in slope-intercept form, but there's also something called the standard form of the line, which we're going to talk about next. The standard form of a linear equation is ax plus by equals c, where a and b and c are real numbers. This is called the standard or the general form. So basically, instead of solving for y, you have all of the x's and y's on one side of the equation and your constant on the other side. All right, for the next few problems, we're going to talk about how we can take a problem given to us in standard form, write it in slope-intercept form, identify the x and y intercepts pretty easily, and then graph the line. And then we're also going to explore some things with horizontal and vertical lines. All right, number 6 is a guided example. We can do that one. We have the equation 4x plus 2y equals 50 to represent Elliot's distance covered, where x is the number of weeks and y is the number of miles covered. So we have a new friend, Elliot. Okay. Write this in slope-intercept form. All we have to do is take the standard form and solve for y. Okay. We can subtract 4x from both sides. So we have 2y is equal to negative 4x plus 50. And then if we divide everything by 2, y is equal to negative 2x plus 25. Okay. Elliot, this isn't good. All right. Let's interpret what's going on here. So what does that 25 represent? The first week, or week 0, he starts off running 25 miles for every workout. And then the next part is asking us about the slope. The slope here is negative 2. So what is the slope of this line? Negative 2. And what does that mean in the context of this problem? Every week, the number of miles that he's running is going to decrease by 2 miles. That's sad. Everybody else is running more. And Elliot's like, no, I run too much already. That's the great sad. So each week, the distance covered decreases by 2 miles. All right, we already talked about part C, so let's write it up. What's the y-intercept? The y-intercept is 0.25, and we would say Elliot's initial distance was 25 miles. All right, and then part D, use the linear equation found in part A to estimate Elliot's distance covered in week 6. So remember, our input represents the number of weeks. So week 6 is telling us that we want x to be equal to 6, and we want to figure out what the distance is, what y would be. So that's y equals negative 2 times 6 plus 25. All right, so y equals negative 12 plus 25. That gives us 13. All right, so by week 6, Elliot's distance covered is 13 miles. Elliot has only like a few more weeks in him before he just quits. He's not running at all. All right, then let's jump to example 7. Kwame maintained his distance covered throughout the several weeks of cardio exercise. His distance covered is 20 miles. Okay, so he's just maintained that same distance the whole time. So what is the rate of change of Kwame's distance covered? Answer using the appropriate units. Let's think about this. If it's saying he maintained the same distance, every week he's going 20 miles, then what is the rate of change? How many miles does his distance change week to week? The average rate of change here would be 0, okay? And if you wanted to think about this in terms of a table, after week 0, it's 20 miles. After week 1, 20 miles. Week 2, 20 miles. Week 3, 20 miles. If you pick any of those ordered pairs and calculate the average rate of change, we'd have 20 minus 20 over whatever weeks. 1 minus 0. 0 over 1 is 0. So yes, the average rate of change is 0. So his change is by 0 miles per week. All right, what does this mean as far as the equation that represents his running distance? So write the linear equation in terms of y equals mx plus b. That would be y equals 0x plus 20, because he started out at 20 miles and kept going 20 miles, which is actually just y equals 20. Doesn't matter what the week is, the output is always going to be 20. We get a horizontal line for Kwame's situation. Because he's maintaining his same distance the entire time, the line isn't increasing or decreasing, it's horizontal. Problem 8 says that we have a vertical line. All right, so Joanna and Fred's graphs are given below. Label each graph with the corresponding names. Sketch the graph that models Kwame's distance covered. What type of line is it? And write the equation of the line. And then draw a line containing all points corresponding to week 4. What type of line have we made? Okay, so we have these two nice people. This first one, the red one, try to color coordinate here. This one's Joanna, because she started off with a lower number of miles and then eventually passed Fred. The second line here, the blue line here, is Fred. For Kwame, I'll draw him in purple. He maintained a distance of 20 miles over all the weeks. So we would just have a horizontal line that goes through 20 for Kwame. Okay. Wait, I missed something. What type of line is this? Y equals 20 is a horizontal line. Okay. And then the next part, we need a different color. Let's go with this one. Draw a line that corresponds to week 4. That will be the line where all of the X values are 4. So this is X equals 4. Then we want the line that goes through this. Boom, we get a vertical line where all of the X values are equal to 4. So what type of line have we made? It's a vertical line. And the coordinate or the equation would be X equals 4. All right. At week 4, use the graph to write the distance covered by Joanna, Fred, and Kwame. We have to zoom in here. All right, so Kwame's easy. We know that Kwame's always going 20 miles. And then it looks like here that, let's see, this is going by 5s. So here at the blue line, this is Fred. Fred is going about 25 miles. And then this red line, let me erase this so I can draw it a little better. For Joanna, it's a little bit below below 30. But if we're estimating, we could say it's about 30 miles. Okay, so for Kwame, 20 miles. For Fred, he was at 25 miles after week 4. And then for Joanna, it says to use the graph. It's close to about 30, but let's go ahead and just find the exact value. 3.5 times 4 plus, I think she started off at 15 miles. Yeah, 3.5 times 4 is 14. So then 14 plus 15 would be 29. So Joanna was 29 miles, very close to 30. All right. Part D, write the equation for the line created in B. We already did that. That was X equals, I wrote it up here. X equals 4. Okay. And then problem 9 is an immediate example where we talk about vertical and horizontal lines a little bit more. A horizontal line is always going to be written as Y equals some number. And the graph will cross the Y-axis at that number. So Y equals -2 is the horizontal line that crosses the Y-axis at -2. And then we're asked to identify the slope. The slope is 0. Horizontal lines have a slope of 0. And the y-intercept is 0, -2, but there is no x-intercept because it's parallel to the x-axis. All right, next, for x equals 5, this is going to be a vertical line that goes through 5. For vertical lines, when we pick 2 points and we try to find the slope, we end up getting 0 in our denominator. So vertical lines have no slope, or we say the slope is undefined. And then for the intercepts, there is no y-intercept. because the graph does not cross the y-axis, but the x-intercept is given by 5, 0. Number 10. We have 7x plus 0y equals 42 in standard form. So if the y is 0, when you write it in standard form, we were asked to simplify this equation. That would be 7x equals 42, and x is equal to 6. So we end up with a vertical line that goes through 6. Let's graph that. This is x equals 6. I should draw arrows on these. And then for part B, if you have standard form where the a term is 0, 0x minus 5y equals 20. Then we end up with negative 5y equals 20. Y is equal to negative 4. That's a horizontal line that crosses the, why am I missing? Crosses the y-axis at negative 4. All right, that's all we're asked to do there. And in the next couple of boxes, this is on page 41, we get a nice summary of horizontal and vertical lines. X equals something is a vertical line, slope is undefined, a comma 0 is the x-intercept. Y equals b is a horizontal line, slope is 0, 0 comma b is the y-intercept, and it doesn't cross the x-axis, so there's no x-intercept. So triad 11 is another one with horizontal and vertical lines. Given the ordered pair 2 comma negative 3, I'm going to plot that point. 2 comma negative 3 is here. Sketch the graph of the vertical line through this point. The vertical line through this point is this line. And then write the equation of the vertical line through this point. The equation of that line would be x equals 2. It's always going to be x equals whatever the x coordinate is. Identify the slope of this line. The slope is undefined. What's the vertical intercept? It crosses the vertical axis at 2 comma 0. What's the horizontal intercept? There is none. So when you're given an ordered pair, if you're asked to find the vertical line that goes through it, vertical corresponds to the x coordinate, so it's x equals whatever the x coordinate is. All right, and the next part asks us to do this, but with the horizontal line going through the point. So again, we have the point 2, negative 3. If we sketch the horizontal line going through this point, that's this line, which is y equals, negative 3. We'll write that down here though. The slope of the line is 0. There is no vertical intercept. And the horizontal intercept is 0, negative 3. And this is the line y equals negative 3. Let's look at number 13. It's a U-triad. We're asked to find the equation of a line that meets the indicated criteria and leave our answer in slope-intercept form. So if we have two lines that have the same slope, those two lines are parallel lines. So parallel lines have the same slope. Okay, here we're asked to find a line that's parallel to this given line but goes through the point 3, 4. So since our line has to be parallel to the one that's given, we know that they have to have the same slope. So our slope m is going to be equal to 2/3, and we're going to be going through the point 3, 4. So this gives us a value for x and a value for y. Then this is just like the problems we did earlier where, hey, if we know the slope and we know the point, we can use slope-intercept form to find b, and then we can write out the equation of the line with the slope 2/3 that goes through the point 3, 4. All right, let's do this. So to find b, we have y equals mx plus b. So that would be 4 equals 2/3 times 3 plus b. So that's 4 equals 2 plus b. And then we subtract 2 from both sides. We see here that b is equal to 2. All right, now remember, we're coming up with a new line. It has this slope, 2/3, and now we just found that it has this y-intercept b. Putting those together, we get y equals, where is it? 2 over 3x plus 2. This is a line that's parallel to 2 over 3x minus 1. They're parallel because they have the same exact slope. But our new line crosses through the point 3, 4.